Welcome student. In this session of mathematics, I am going to start chapter square and square root, cubes and cube root. That is chapter 3. In the first part, we will be discussing about square and square root. So what does the word square means? If I say x square, it means x into x. If I say 4 square, it means 4 into 4, that is 16. But by mistake, a few children understand 4 square is 2 into 4. That is wrong. Okay? It's not 2 into 4. 4 square means 4 into 4. Then I discuss the word perfect square. See, perfect square numbers are those numbers which are the product of any number with itself. If I say 1 is a perfect square number, so that means 1 can be replaced by 1 into 1. So it is a perfect square number. If I say is 2 a perfect square number, can you suggest me any number which when multiplied by itself will give you 2? Do we have any such number when multiplied by itself will give you 2? No. So it's not a perfect square. Then I talk about 4. Can you suggest me any number which when multiplied by itself will give you 4? Yes, that is 2. So we can write 2 into 2. So therefore 4 is a perfect square. Then I talk about 5. Can we write 5 as a product of any number with itself? No. So it's not a perfect square. Similarly, we can write 6 as 2 into 3, which is not the product of number and itself. Okay. So 6 is not a perfect square. Okay. Then I talk about 9. 9 can be replaced by 3 into 3. That is the number and the product with itself only. That is 3 into 3. So 9 is a perfect square number. Remember children, square means power is 2. Square root means power is 1 by 2. And the symbol for square root is this way. Okay. So what we learned in square, the square of a number is the number raised to the power 2, that is the product of number with itself. Perfect square are any perfect square number. A natural number is called a perfect square if it is the square of some natural number, or we are looking for any such number when multiplied with itself give you that number. If it is possible, then it is a perfect square number. Then I come to the square root. The square root of a number is that number which when multiplied by itself give you x as the product. See, this is a symbol for square root. If I say square root of x, then we represent it with this way. Now I start with exercise 3a. Before we start with exercise 3 in the fair copy, student, first you'll write the squares of numbers from 11 to 30. How we write it? 11 square is 11 into 11, that becomes 121. 12 square is 12 into 12, that is 144. 13 square is 13 into 13, that is 169. This we will continue writing up to 20 in the first column. Then we'll draw a line with the pencil and the ruler, and then we'll write the square of 21, square of 22, and this we will complete up to square of 30, that is 900. So before we start with exercise 3a, first we'll write the squares from 11 to 30 in the fair copy. Then we start with exercise 3a. What they are saying in exercise 3a, question number 1, they are saying find the square of each of the following numbers. So question number 1 has 8 parts. We'll do all the parts because we have to only simplify it by finding the square of the numbers. See how we do it in the copy. First you write the squares from 11 to 30 as I said. Then question number 1. Fourth part I have done. Square of 2 whole 3 by 4. First you write the mathematical expression showing that we are finding the square. Then I converted this mixed fraction into an improper fraction, that is 11 by 4 square. It means 11 into 11 and 4 into 4. That becomes 121 upon 16. Again, it's an improper fraction. We convert improper fraction into a mixed fraction. So I have written 7 whole 9 by 16. Then I have considered one more part of it. It is square of 0.117. So that means 0.17 into 0.17. So whenever we have decimal, product of decimals, please do not multiply in a long method. Firstly, multiply the numbers. So 17 into 17, when you will multiply 17 into 17, it is 289. Okay, I have written 289. Now decimal after how many places? Here 2 places, 1 to 2 places, here 4. Total we'll put the decimal after 4 places. So what the answer is? 0.0289. Okay, student, learn the squares from 11 to 30. The moment you learn it, it becomes your calculation easy. See, I have learned the 17 square is 289, so I have written the answer directly. Okay. Then I discussed question number 2. They are saying, using prime factorization method, find which of the following are perfect squares number. So we are using prime factorization to find out whether the given number is perfect square or not. It has 8 parts. We'll do the last 4 parts in the fair copy. See how we do it in the fair copy. I've taken question number 2, 8 part. I've done the prime factorization of 9075. So it goes with 5. And this way I have done the prime factorization of 9075. Now we write the prime factorization of 9075. We find that we have a pair of 5. We have a pair of 11, but 3 is not having any pair, that is, it is not having any square of it. So we'll write, as 3 is left unpaired, therefore 9079 is not a perfect square. See, for any number to be a perfect square, we should have all the numbers in the pairs. If any number is not having the pair, that means it is not a perfect square. Because 5 has power 2, 11 has power 2, but 3 is not having power 2, so therefore it is not a perfect square. This way we leave our answer saying that 9075 is not a perfect square. So hope you can do the remaining bits of this. Then I discuss question number 3. Question number 3, they say, show that each of the following is a perfect square. So firstly we have to show that it is a perfect square and also find the square root of each. Then we are looking for the square root. So again we'll do the last 4 parts. I discussed question number 3, 8 part with you, that is 8281. Firstly, whenever we have to find the square or square root, we do the prime factorization. So I do the prime factorization of 8281. So it becomes this. So I've written the prime factorization of 8281 is 7 into 7, 13 into 13. See, we find that 7 is also square, 13 is also a square, is available here. So 82181 can be expressed as a pair of equal factors. We'll write the reason, as 8281 can be expressed as pair of equal factors. Therefore 8281 is a perfect square. Okay, now we have to find the square root of 8281. So we put in under the symbol of square root, and now we write the prime factorization. We have the pair of 7, we have a pair of 13. I told you square root means power half, so power will become half. 7 is having power 2, that becomes half, that is 1, 7 to the power 1. And 13 is having power 2, that also becomes half, that is 13 to the power 1. Now we multiply 7 and 13, that becomes 91. Therefore the square root of 8,281 is 91. So this way we have understood question number 3 how to be solved. Then I again do the last 4 bits of question number 3 also. Question number 4 we come to. They are saying find the smallest number by which each of the following numbers must be multiplied to get a perfect square number. It's very sure this is not a perfect square number. So we do the prime factorization and then we'll find which number is left unpaired. Whichever number is left unpaired, we'll multiply it with that number and it will become a perfect square number, and then we have to find the square root of the resulting number. Question number 4 has 4 parts, so we'll do all the 4 parts. I'll do the last part for you. Question number 4, it is 3,380. Firstly, we have to do the prime factorization of 3,380. I've done. So we find we have a pair of 2, we have a pair of 13, but what is unpaired? 5. So first we write the prime factorization here. So we'll write as 5 is left unpaired. When we did the prime factorization, we find that 5 is not having its pair. So we'll write 5 is left unpaired. Therefore, 3830 must be multiplied by 5 to make it a perfect square number, and therefore we multiply 3380 with 5. So what we'll get? It is 16,900. So we have multiplied it with 5 to make it a perfect square. This said, the moment it is converted to perfect square, find the square root also. So we have find the square root of 16,900. So we can replace it by 2 into 2, now 5 into 5 and 13 into 13. Square root means power to be converted half. So power 2 has power 2, so it becomes half, that is 2 to the power 1. For out of this pair we'll take 1. Out of this pair of 13 we'll also take 113. So what the product is? 5 2 is 10 into 13, that is 130. So the square root of 16,900 is 130. Then I discuss question number 5. They're saying by which least number should be the given number be divided to obtain a perfect square number. So again it's very sure it is not a perfect square number. We have to now divide. Instead of multiplying, we have to divide it, and we have to find the square root of the resulting number. Okay children? See student, again we'll do question number 5 also exactly the way we did question number 4. First we will do the prime factorization and we'll find which number is left unpaired. Now in place of multiplying, we'll divide it. So we'll strike off multiplied, and what we'll write in place of divided. So we'll divide. What is left unpaired? It is 5. So we'll divide it by 5 to make it a perfect square. And then we'll, after dividing, we'll write the resulting number and then we'll find the square root of it. Okay. See question number 4 and 5 to be done with the same method, but instead of multiplication, what you have to write? Divide. And again you have to find out the square root of that number. I discuss question number now 6 with you. 6 and 7 again are of the same type. So I discuss question number 7. In an auditorium, the number of rows is equal to the number of chairs in each row. If the capacity of the auditorium is 2025, find the number of chairs in each row. See how we do it in the copy. Let the number of chairs be x in each row. Therefore, number of rows will also become x as it is given in the question. It is same. Total capacity of auditorium, how we find out? How many rows are there and how many chairs are in each row. Number of chairs in each row. Number of chairs in each row into number of rows. That give you the total capacity. That is x into x is equal to 2025. X square is 2025. Again do the prime factorization of 2025 and then you will find it is a square of 45. You can do prime factorization of 2025 in your rough column. Therefore, x is equal to 45. Therefore, number of chairs and number of rows is 45. Okay. Now, I discuss question number 8. Find a least square number. The moment they say least, it is related with the word LCM. Square, that means we are looking for the perfect square number, which is exactly divisible by 8, 9, 10 and 15. So we are looking for the least square number which is exactly divisible by 8, 9, 10 and 15. How will do this question? First you will find the LCM of 8, 9, 10 and 15. After finding the LCM, we'll do the prime factorization of the LCM and then we'll find whether it's a perfect square or not. So if it is not a perfect square, we'll multiply the same number which is unpaired and then we'll get the least square number. Let's have a look on solution of question number 8. The same variety I have taken the example question of. See again question number 5. Example number 5 is of the same type. Find the least square number divisible by 12, 15 and 20. So whenever they say such things, first we find the least, that is LCM. So we find the LCM of 12, 15 and 20. When we find out the LCM is 60. Okay. Now we do the prime factorization of 60 as they have done it here. Now which is left unpaired? See, 60 has 2 is in pair, 3 is unpaired and 5 as well is unpaired. So we multiply with one more 3 and with one more 5. So to make it a perfect square, it must be multiplied by 3 into 5, that is 15. Hence, as we are looking for the least square number, so the least square number is 60 into 15, that becomes 900. Okay, so what we'll do in question number 8? First, we'll find the LCM of 8, 9, 10 and 15. After finding the LCM, we'll do the prime factorization of it. After doing the prime factorization, which numbers are left unpaired in prime factorization, we'll multiply with those numbers. Then you'll get the least square number. Okay, children? So at this way, I've discussed exercise 3A. Complete all the questions of exercise 3A. That's the end of the session. Be safe and keep studying, children.